Alright, in this video we will be working an infinite limit example that's a bit more challenging than the basic examples that we've worked before. As with any limit, we'll start by plugging in x equals a and see what happens. So in the numerator we get 1 plus 5, and in the denominator we get 1 minus 1 squared. So 6 over square root of 0 is 6 over 0. This has number over 0 structure, and when we see that structure, our technique is one-sided limits. We'll begin with the left-sided limit. The limit as x goes to 1 from the left of x plus 5 over the square root of x minus x squared. Now here, if we try to plug in the 1 minus and work out what's happening, we could piece this together, but the logic is a bit more challenging. So instead of doing that, I'm going to first factor the radicand, the stuff inside the square root. Hopefully that will help me see what to do more easily. So that factors as x times the quantity 1 minus x. And now if I stick in the 1 minus, in the top I'm going to get a 6 minus. And in the bottom, I'm going to get something that looks like the square root of 1 minus times the square root of 1 minus 1 minus. Now, 1 minus is a little bit less than 1. So the square root of 1 minus is also a little bit less than 1. And then 1 minus is a little less than 1, so this difference is a little bit bigger than 0, because 1 minus is like 0.9. So 1 minus 0.9 is positive. And the square root of 0 plus is 0 plus. Now we need to be a little bit careful in this interpretation. These minuses here do not mean negative. They mean a little bit less than. So 6 minus is a little bit less than 6, which is still positive. So in the numerator we have a positive. And then in the denominator, again, 1 minus does not mean negative. It means a little bit less than 1. Something like 0.9, so that's positive. And then this 0 plus here is obviously positive. So we have a positive divided by positive times positive. The end result is positive infinity. So this result is positive infinity. Now if we do the right side, the limit as x goes to 1 from the right, I'm going to go ahead and factor the radicand again, because I already know the logic will be too difficult if I don't. Here, I'm going to try plugging things in and see what happens. So 1 plus 5 over the square root of 1 plus times 1 minus 1 plus. Now 1 plus means a little bit bigger than 1, so the numerator is a little bigger than 6. In the denominator, we have a 1 plus inside that radical times, and now again 1 plus means a little bit bigger than 1, so something like 1.1, 1.01. So if we do 1 minus 1 plus, that's like 1 minus 1.1 is negative 0.1, so that's 0 minus. So this is 0 minus. Now a little bit less than 0 is negative, so this is 6 plus over the square root of negative 1 plus. Now again, this plus here does not mean it's positive. It means it's a little bit greater than the number below it. So our number below it is negative 1. A little bit greater than negative 1 is something like negative 0.99, a bunch of 9s. That negative 0.9999 stuff lives inside a radical, which is imaginary. Square root of a negative is imaginary. So this is not real, non-real, otherwise known as imaginary. And so the limit does not exist. Now, not only do the left and right limits not agree, they're not the same. So we can see these are not the same. That would be enough for us to say the overall limit, the two-sided limit we were seeking from the beginning, does not exist. But in fact, because the right-sided limit does not exist, it doesn't matter what the left-sided limit is. As soon as one of the sides is undefined, the two-sided limit is undefined. Therefore, the original limit as x approaches 1 of x plus 5 over the square root of x minus x squared does not exist.